Report writing guidelines for experiment 3B, energy. Please write your experiment report in the lab report writing session provided in a physics practical workbook. Learning outcomes. At the end of this lesson, students should be able to verify the law of conservation of energy. A warm reminder. All the values shared under the observations are just for your reference to ease in explanation. You are not allowed to copy and use the values for your experiment report. Any value found the same in your experiment report are against the scoring rubrics, as no plagiarism is allowed. You must write your own lab report. You are not allowed to copy your peers' experiment report. Any doubts found in the originality of your experiment report are against the scoring rubrics. Observations. Data tabulation. Make sure all the columns headers are labeled properly with the physical symbols and units. The number of decimal places for primary data must follow the sensitivity of the instrument used. The number of decimal places for the secondary data are rounded off to consistently 2 or 3 decimal places. Calculation of centroid point. In general, the centroid point is written as mean x, mean y. We are plotting graph of v squared against h. Therefore, the centroid point of this experiment is written as mean h, mean v squared. Calculate mean h and mean v squared. And the centroid point will be 37.5 cm, 8.61 times 10 to the power 4 cm squared per second squared. Remember to mark the centroid point on the graph of v squared against h, then circle it to differentiate the centroid point from the other data points. Plot graph of v squared against h. First, the title of graph is written. Then, the y-axis is labeled with units and the x-axis is labeled with units. The size of graph is more than or equal to 50% of the graph paper. All data points are marked correctly on the graph. Appropriate scales are used for both sides. For example, 1, 2, 3, 2, 4, 6, 5, 10, 15, 10, 20, 30. A balanced best fit line through the centroid point is drawn. Sides x and y for the triangle of gradient are more than or equal to 8 cm. Centroid point is marked and circled. This is the example of not balanced straight lines. As you can see, the left and the right of the graph, the number of data points for both sides are not balanced if you draw the blue line. And as you can see, below the centroid point is towards here, whereas above the centroid point is going up. So all must be balanced. Then only called best fit line. Determine the gradient of the graph. For the operation of addition and subtraction, the number of decimal places of x and y entries must be consistent. M best equals to y2 minus y1 over x2 minus x1. The number of decimal places that we need to put It depends on the half of the smallest division of the scale used for both x and y axes. Based on the graph plotted in previous slides, for the y-axis, 10 divisions between 4 and 5. So half of the smallest division will be half times 1 over 10, and you will get 0.05. So the y entry consists of 2 decimal places. For the x-axis, 10 divisions between 15 and 20. So half of the smallest division will be half times 5 over 10. The answer is 0.25. Therefore, the x entries consist of 2 decimal places as well. For the operation of multiplication and division, the least of the number of significant figure of the x and y entries is considered and reflected in a calculated value of gradient m obtained. For example, 13.50 is 4 significant figure. 4.40 will be 3 significant figure. 56.00 will be 4 significant figure, whereas 22.00 will be 4 significant figure. Among the x and y entries, the least number of significant figure is 3. It can be allowed to add one more significant figure, become 4 significant figure. Therefore, the value of m is rounded off, becoming 2.68 times 10 to the power 3 cm per second squared. Determine the uncertainty of the gradient delta m using Excel. This is a sample of a blank sheet. Fill up the column x with the value of r squared. Fill in the value of gradient m obtained from the graph. Fill up the column y with the value of h. And lastly, the delta m calculated by Excel. Please record it down in your workbook. M best equals to 2.68 times 10 to the power 3 centimeter per second squared, whereas delta m equals to 0.47 times 10 to the power 3 centimeter per second squared. Please round off the value of delta m to the same decimal places as m obtained. Here, 2 decimal places, and delta m also 2 decimal places. Thus, m plus minus delta m equals to 2.68 plus minus 0.47 total bracket times 10 to the power 3 centimeter per second squared. Both also 2 decimal places. Determine the acceleration due to gravity g. From the equation 3.3, v squared equals to 2gh. By comparing with the linear equation y equals to mx plus c, the gradient m best will be equals to 2g. Therefore, the acceleration due to gravity will be g equals to 1.34 times 10 to the power 3 cm per second squared. If convert into meter per second squared, there will be 13.4. Based on page 2 in the Physics Practical Workbook, deduce the formula of delta G using the combination of uncertainties. M best equals to 2G. Will become delta M over M best equals to delta G over G. Therefore, delta G will be equals to delta M over M best times with G. So the final answer will be 2.33 meter per second squared. State the result obtained. G plus minus delta G equals to 13.40 plus minus 2.33 meter per second squared. We need to always round the experimental measurement or result to the same decimal places as the uncertainty. Experimental uncertainty should be rounded to one significant figure. Therefore, G plus minus delta G is equals to 13 plus minus 2 meter per second squared. How many digits should be kept? To be consistent with the large uncertainty in the uncertainty, value should be stated to only one significant figure, or perhaps two significant figures if the first digit is a 1. In short, experimental uncertainty should be rounded to one or at most two significant figures. How many digits should be kept? Experiment uncertainties should be rounded to one significant figure. For example, 9.23 plus minus 2.22 cm. You need to round off to become 9 plus minus 2 cm. Always round the experimental measurement or result to the same decimal places as the uncertainty. For example, 9.23 plus minus 2.22 second will become 9 plus minus 2 second. Or the other example will be 9.23 plus minus 1.22 second. The correct one will be 9.2 plus minus 1.2 second. Calculate the percentage of uncertainty. The formula is delta G over G times 100%. And the answer is 15.38%. Calculate the percentage of difference. The formula is modulus actual value of G minus experimental value of G divided by actual value of G times with 100%. And the answer is 32.52%. Discussion. State the results obtained in the form of G plus minus delta G meter per second squared, the percentage of uncertainty, and the percentage of difference. State the possible errors occurred in the experiment and elaborate. State the precaution steps taken in the experiment. Conclusion. State whether the learning outcomes or objectives of the experiment could be determined by the experiment. A warm reminder. Please check with your lecturer when to submit your experiment report, as your lab report will be evaluated based on the report writing skill scoring rubrics provided in the Physics Practical Workbook.